All right, so welcome to lesson 5.5. We've been multiplying scientific notation for 2 days now, or 2 lessons. Now we're going to do dividing for 2 days. All right, so let's remind ourselves how to multiply scientific notation, right? 3.4 times 2 that's 2 times 4 is 8, times 2 times 3 is 6, and we get 6.8 times 10. We add the exponents, and you get positive 2. Right, and this is the same as 3.4y to the fifth times 2y to the negative third. You would multiply the coefficients and you would add the exponents. Same pattern. You already knew how to do that. So is today's division of scientific notation going to follow the same sort of rules? Let's see. So, right, 35x to the sixth divided by 5x squared, right? The coefficients get actually divided. We cancel this x squared and that becomes a 4, and we get 7x to the fourth over 1, or 7x to the fourth. Here, 12 divided by 2, right, is 6, right? Now, you could flip that up there and add them, or we could, yeah, let's do that. Let's rewrite this. So that becomes 6y to the eighth with y to the third up there, and so that becomes 6y to the 11th. But we also could subtract. 8 minus negative 3 is the same as 8 plus 3, which is that 11. All right, so same thing here, right? We could flip this all over and do that and realize it's x cubed, or we could subtract negative 2, right? So when you're dividing, right, you subtract the exponent. So it would be negative 2 minus negative 5, which is the same as negative 2 plus 5, which is 3. Two ways of getting the same answer. Okay, now, so we're going to be dividing scientific notation, right? So it's literally this, 8 divided by 4 is 2, these cancel, and you get 10 cubed. Divide scientific notation, we divide the decimals and powers separately. All right, we subtract the exponents, right? When you're multiplying, you add the exponents, we subtract them. So we're going to do that today. Now, what's different about these rules than the rules we had is negative exponents are left, right? Because you can have negative exponents in scientific notation. So 6 divided by 2 is the 3. I'll just show it fully, right? And then 9 minus 4, right? 9 minus 4 is 5. 3 times 10 to the fifth. It's that easy to divide with scientific notation. All right, now here's the difference here, right? 9 divided the coefficients. These aren't coefficients, but they're just treated like that, right? That becomes a 3. And now we have to do 5 minus 7, right? 5 minus 7 is negative 2, right? Because they would be down here, right, if you did the canceling way. So that's really the only tricky part of the day, right? It's not 7 minus 5. It's top minus the bottom. 5 minus 7. All right, so 9 divided by 2. All right, so now it doesn't go in. Now remember, we want this first number to be a decimal. That's what the notes are trying to do. So we're going to do 2 divided by 9, right? 2 times 4 is 8. Remainder 1. Decimal straight up, 0 straight down. 2 into 10, 5, right? That makes sense, right? Because 8 over 2 is 4. So 9 over 2 is 4.5, also known as 4.5. So that's 4.5. 8 minus 2 is 6. So 9.6 divided by 3. 3 goes into 9 3 times. Decimal straight up. 6 straight down. If you could do this in your head, that's fine. 3.2 times 10. Now we have to do 2 minus negative 7. 2 minus negative 7. 2 plus 7, 10 to the 9th. So we divide 5.8 divided by 2. Decimal straight up. 2 into 18, 9. 2.9, we just keep the exponent, times 10 to the negative fourth. Scientists found 3 asteroids with a total mass. And here we're given the total, and we're finding the average. How do you find the average? You divide, right? You take a bunch of number, you take a number, and you divide it by how many there were. So we have to do 8.1 divided by 3. 3 goes into 8 twice. 3 goes into 21 7, decimal straight up. And so this is 2.7 times 10 to the 9th kilograms. How many times larger? Remember when we did that? What kind of problem is that? Division. Now the bigger number has to go up top. 10 to the 12th, right, is bigger. So we're going to see how much bigger that is. Whenever you see this, how many times larger, that's a division problem. All right, so 8.4 divided by 2. 2 goes into 8 4 times. And 2 goes into 4 2 times. And you get 4.2 times 10. And we're subtracting the exponents. And it's 10 squared, or 10 to the second. All right, so what does that mean? It's that, or what is that number? 420 times bigger. You could have written it either way, because it doesn't say put the answer in scientific notation. Okay, let's try a little more difficult division, although barely, right? You're not allowed to have a decimal up there. What do you do about that? You move the decimal point and make that 21. Once you do that, you move that and make that 42. 21 goes into 42 very nicely. If you could just see that, that's fine. So this is 2 times 10, and we have to do 7 minus 10. I'm going to start writing it up there, which is negative 3. 2 times 10 to the negative third. Word practice. 9 divided by 5. Right, it's the top divided by the bottom. So that goes in once. Goes in 8, so it's 1.8. I'll finish this. 1.8 times 10, 15 minus 2, 13. 6 divided by 5. 5 goes in once. Decimal straight up, right? There's a decimal point in 6. 5 to 10, 2, so it's 1.2. Now times 10, and we have to do negative 2 minus negative 5. What's negative 2 minus negative 5? It is, right, same as negative 2 plus 5, or 3. How many times larger? So the bigger one is the one with the 6 exponent. 3 goes into 9.3. 3 times 3 is 9. Whoops, 9. Decimal straight up, 3 straight down. So you get 3.1. And 6 minus 3, I'll write it out, is times 10 cubed. That's how many times bigger. Now if I move that 3 times, I would get 2 zeros. It's 3,100 times bigger. It's way, way bigger. What does that mean? This number times 3,100, yes, gets you that number. It's 3,100 times bigger, 3.1 times 10 to the third. All right, the total weight is that. All right, so now this is easy because you know it's division today, but realize you're going to have to read them on the test. All right, so I'm giving you the total and we're finding the average. On the multiplying ones, I gave you the average and you multiplied to find the total. You're going to have to read. And this is a word problem, so we're going to put a word, grams. Time of travel, by the way, yeah, I skipped over this a little bit in the last lesson. The time of travel equals the distance divided by the rate. Yeah, the other day you did distance equals rate times time. You hopefully learned that in 6th or 7th grade. So we're doing this one today. So the distance, we're traveling a total distance of that, right? And the light travels at a rate. R is rate, D is distance, and T is time. And it's, right, it's that 3 times 10 to the 8th, which is 300 million meters per second. Yeah, that's how fast light goes. And 9 divided by 3 is 3. Ooh. And so 10 to the 8th times 10 to the 8th, 10 to the 8th divided by 10 to the 8th is 10 to the 0th, right? So this is 3. How many seconds will it take to travel 9 times 10 to the 8th? It'll take 3 seconds, right? That makes sense. It's going that far in 1 second, meters in 1 second, meters per second. So in 2 seconds, it goes 6 times 10 to the 8th. In 3 seconds, it goes 9 times 10 to the 8th. How far would it go in 4 seconds? 12 times 10 to the 8th. But 12 times 10 to the 8th, not in scientific notation, but it is equal to that.